Hi again, AP Calc students. This could be the lesson you're waiting for, especially if you're just coming from pre-calculus when we did a lot of limit stuff. Here we're going to learn the shortcuts for differentiation. And lots of rules here maybe get a bit confusing at first, but eventually you'll get to be really good at these. So the shortcuts have arrived. Here we go. First of all, the derivative of a constant. Now by a constant we mean just a single value or single number. So for instance, if we had something like this, the f of x equals 6, that's just a straight horizontal line if we were to graph that, and certainly we would say that the derivative of that is going to be 0. Why? Well, remember, derivatives are essentially slope, and so the slope of a straight horizontal line will always be just 0. Alright, the next one, the power rule. I would say this is probably the one we'll use the most often. I'm going to put a big asterisk by this. We'll use this an awful lot. Notice what this says. If we have the derivative of some power, what we end up doing is taking that power and using it as a coefficient, in other words multiplying it by the x, and then my power reduces by 1. So for instance, what this might look like, if I have the f of x equals x squared, as we've seen this one numerous times it seems like, the derivative of that will be, I put that 2 out in front, times x, and then my power decreases by 1, so it's just x to the first power. So this is a real huge one. Let's just try another quick example here. Let's say if I had f of x equals x to the fourth minus x to the third. So again, the derivative then, according to this power rule, would be 4x to the third. Remember, the powers always come out in front, minus 3x squared. So that's the shortcut rule for powers, and again, we'll be using that a lot. Alright, constant multiple rule. This one we'll use a little bit, for instance, but let's just say that I had y equals 4 times 2x to the third, like that. Well, basically what that's saying is that constant, which is the 4, if I'm doing the derivative of that, that constant can stay there. Okay? That 4 is just going to stay there. Now I just need to find the derivative of what's in the parentheses here. And by the power rule, we take 3 times 2, which is 6, times x, and then my power decreases by 1, so something like that. Okay? Again, fairly similar to kind of a combination of what we've seen earlier. Alright, sum and difference rule. Here's another one that's pretty useful. We'll use that quite a bit. This is just saying that if you have the derivative of a sum or difference, basically you're just going to take the derivative of each single thing. So for instance, if I had the g of x equaling negative 2x to the fourth plus 5x squared minus 7x, and I want to try to find the derivative of that, I just go along and take the derivative of each single item. So first of all, my negative 2x to the fourth, the derivative would be negative 8x to the third, plus, now I just take the derivative of the second item here, which would be 10x, and finally the derivative of the last one, which would just be negative 7. Sum and difference rule. Notice those are separate terms when we go ahead and do that. Alright, now we start getting to the fun stuff. Here's the product rule. Again, this looks pretty difficult. The derivative of u times v, u times dv over dx, plus v times du over dx. But I think if you remember this verbiage right here, this might be the most helpful. The first times the derivative of the second, plus the second times the derivative of the first. So let's actually try one of these here. Let's say that I have my f of x equaling, and I'm just going to leave this in product form here, 3x minus 5 times x squared plus 6x. And I want to try to find df over dx, in other words, another way of writing the derivative. Alright, so we're just going to follow through here. I'm going to take the first, which is 3x minus 5, times the derivative of the second. And so now we've learned by the power rule that's going to be 2x plus 6. Here's my addition sign now in between those, plus the second, so I just write the second one down again, which was x squared plus 6x, times the derivative of the first. The derivative of the first, since it's just a 3x minus 5, will simply be just 3. And I'll go ahead and simplify this. I've multiplied this out. You may want to check my work, but eventually when I multiply all these out using the FOIL method, I'm just, you can do a little preliminary work. I believe your final answer should be 9x squared plus 26x minus 30. And you might wonder, well, do you have to simplify it as much as you can, or could I just leave it like this? Kind of depends. Most of the time we will try to multiply it and simplify it as much as possible. Again, remember what this shows. If I have some ugly function like this, when I find the derivative, essentially it will tell me what the slope of this monstrosity is at any particular point. So that's the product rule. Again, we'll be practicing on that quite a bit. Now here's the fun one, the quotient rule. The quotient rule. And as you can see, this looks kind of complicated. U divided by v, v du minus u dv over v squared. But here's the way to remember this. You might want to think of the old seven dwarfs here. If we have high, which means the numerator, whole, which means the denominator, high whole, so then we can abbreviate this or help you remember this quotient rule by saying ho d high, that's the denominator times the derivative of the numerator, minus high d whole. So that's the numerator times the derivative of the denominator, all that over ho squared, and so that's the denominator squared. So ho d high minus high d whole over ho squared. Alright, I am going to try one of these problems here for you, and I'm just changing my pen color a bit and my pen thickness. Let's try the same functions essentially that we had before. So let's say that y equals 3x minus 5 over x squared plus 6x. And here's my y prime. Now I'm going to follow my goofy little rule here. So ho, that's my denominator there, so x squared plus 6x, times the derivative of the high, and the derivative of 3x minus 5 is just 3. Minus, again, where I'm at here now, I just did this. Now I'm going to this part. So now I go to the high d whole. So the high is, and by the way, I'm going to put some big brackets around here. My high again is 3x minus 5. And the derivative of the denominator, or the low, will just be 2x plus 6. Okay? And don't forget about my denominator. That's the whole squared, so basically that is the x squared plus 6x. All of that squared. So that's kind of a mess, as you can see. Here's what I got. You can kind of check my work. You have to use a little distributive property at first. So 3x squared plus 18x. And then when I multiplied these guys together, again, that's just my FOIL method there, and combine those a little bit, I ended up with 6x squared plus 8x minus 30. All of that over the denominator squared, which I think ended up to be x to the fourth plus 12x cubed plus 36x squared. And in simplifying all that, here's my final answer. You can check this out. I came up with negative 3x squared plus 10x plus 30 all of that over, same thing I just had, x to the fourth plus 12x cubed plus 36x squared. So that's a lot of algebra there. In fact, we'll talk about in class that a lot of times the calculus isn't so hard, but it's just the algebra that's involved with it is the difficult part. But that's the quotient rule. Again, we'll be practicing on that bugger as well. Here's another power rule, this time with negative powers of x, negative integer powers of x. So for instance, I'm going to change my pen color here. Let's say if I had the k of x equaling 3x to the negative fifth power. So what would the derivative of that be? Well, this is really just like the power rule we learned earlier, except we have negative exponents, but it doesn't really bother anything. So I take the negative 5 times 3, which would be negative 15. Now the question is, what happens to my power of x? Well, remember, your powers of x always decrease. So what is 1 less than negative 5 would actually be negative 6. Now another way to write this, which sometimes comes in handy for us, is remember a negative exponent could become positive exponent when we put it in the denominator. So it looks like that. That's the power rule. Alright, almost higher order derivatives. Now we've taken just the first derivative so far, but we could actually keep taking derivative and derivative and derivative. Let's see what that might look like for one like this. Here's a y equals expression. The degree is 3, the biggest power is 3. So my derivative here by now, we've learned the power rule, so this is just going to be 6x squared plus 8x minus 2. That's called the first derivative. Now we can take the second derivative, and this has some really nice applications physics-wise, as we'll learn. Second derivative is just taking the derivative of the derivative. So I look at the one above, and it's going to be 12x plus 8. And then I could take the third derivative even. This does even have a practical physics application. That's just going to be 12. Remember, the derivative of a constant is just 0, so there's no need to really write that down. And if I wanted to, I could even have a fourth derivative here. The derivative of a constant, of course, is 0. So that's higher order derivatives. Alright, a lot of stuff packed in here, but these are shortcuts that will definitely help you for the rest of this course. Alright, thanks for listening, everybody. We'll see you guys in class.